In today's lesson, we'll be learning about the quadratic formula. The quadratic formula is used to find the x-intercepts of a quadratic relation. If you're given its graph, it's quite easy to find the x-intercepts. Over here, you can see that the x-intercepts are positive 3 and positive 5. However, if you're given the equation of the quadratic relation in standard form, that really only tells you the y-intercept. It also tells you the direction of opening and if it's being stretched or compressed, but those aren't very useful here. If you're given vertex form of a quadratic relation, that really only tells you about the vertex, and the vertex here would be positive 4 and negative 1. It also tells you if it's opening upwards or downwards and if it's being stretched or compressed, but again, that's not too useful. If you're given factored form of a quadratic relation, well, you can tell that the x-intercepts are positive 3 and positive 5. It also tells you if it's opening upwards or downwards, as well as if it's being stretched or compressed. But what happens if you're not given its graph or factored form? How do you find the x-intercepts? As stated at the beginning of the lesson, the quadratic formula is used to find the x-intercepts of a quadratic relation, and it is used if you're given standard form. In the top right, you'll see the general form of standard form. A represents the coefficient of x squared, B represents the coefficient of x, and C represents a constant. In our particular situation, the A value happens to be positive 1. Our B value happens to be negative 8, and our C value happens to be positive 15. Once you have your A, B, and C values, you can substitute them into the quadratic formula. So I'm going to put negative 8 where B is, I'm going to put positive 1 where A is, and I'm going to put positive 15 where C is. To simplify the quadratic formula, you'll need to use BEDMAS, or the order of operations. The first thing you want to do is this, negative 8 to the power of 2, which is the same thing as negative 8 times negative 8, which makes positive 64. Everything else stays the same. Next, we are going to simplify this. There's actually a negative 1 in front of the bracket, so negative 1 times negative 8 becomes positive 8. Over here, this is all multiplication. So we are going to go negative 4 times 1 times 15, which becomes negative 60. The 64 remains unchanged, so let's just recopy that. Next, let's simplify the denominator. The denominator is 2 times 1, and 2 times 1 is just 2. Next, we're going to simplify this under the square root. So 64 subtract 60 becomes 4. Everything else stays exactly the same. Next, we're going to take the square root of 4. And if you recall, when you take the square root of a number, there's a positive and negative answer. So the square root of 4 is positive or minus or negative 2. The 8 and the 2 stay exactly the same. That's where this little symbol comes from, this plus or minus. We now have two paths to take. We have 8 plus 2 over 2, or we have 8 subtract 2 over 2. Let's start with the top for now. So 8 plus 2 is equal to 10. The 2 on the bottom stays the same, and 10 over 2 simplifies to just 5. So one of our x-intercepts are 5. On the bottom, we have 8 minus 2, which is 6, and the 2 on the bottom stays the same. 6 over 2 simplifies to just 3. So 3 would be our other x-intercept. So as you can see, you can determine the x-intercepts of a quadratic relation using the quadratic formula if you're given standard form.